All right. Well, so we're on session 9, which is cross connection. So one of the poll questions I don't know that we've ran, it would be an interesting one to run, is how many people are taking examinations. And I'm just going to give you a big every single certification exam has questions about cross connections, and they are in references to the devices and assemblies, how they're used, where they're used, and so on and so forth. So for exam preparation, I highly recommend that this is a presentation that you do pay attention to or have attended other classes in. All right, so without further ado, let's go ahead and start. I always run into this problem. There we go. So what are we going to cover? We're going to, we'll just go over it. So why are cross connections a big problem? The fact that they're a big problem is the fact that cross connections pose a huge risk as far as contamination goes. In 2019 alone, Corpus Christi, Texas had 5 major backflow events that had affected more than 500 people. So backflow events can be a big issue. And if we had to guess, why do we think it's a big issue? Well, about 70% of all waterborne illness, sicknesses, and deaths that occur, though a vast majority of cross backflow prevents go unreported, 70% of all illness, sickness, and deaths are directly related to cross connections in a water system, all right? So it can be a big deal. And a lot of times when I say they go unreported is the fact that a lot of them occur in like residential settings where there could be a backflow event, say from the Miracle-Gro can that people put on their hoses and such for their yards. If a water main break occurs, it could backflow into your system, and maybe possibly even just affect you and your neighbors. Well, a little bit of Miracle-Gro or whatever. I'm not saying it absolutely is not good for you at all, but most of the time it'll give you like an upset stomach, and lead to a little bit of bathroom issues or whatever. And the thing about that is most people chalk up a upset stomach to the fact that they go, oh, it's because I ate something that wasn't upset my stomach or something along those lines, right? So the laws and rules and guidance documents for cross connections come from part 14. They also come from the plumbing code. They come as part of the 10 state standards, which is an agreement that Michigan has with all the surrounding Great Lakes states and provinces like Ontario. There's some stuff there. We have the Eagle Cross Connection Control Manual. And then there's also local ordinances, depending upon what the ordinances is the city has, saying that residents should follow for certain things. What we got here? Not chat. Okay. All right. I clicked up there, it's all messed up. So what are we going to talk about? We're going to talk about what a cross connection is, backflow, and then we will also talk about the devices and assemblies. All right. So these are different types of backflow events that could occur. So one thing that you have here is under normal flow, you see the water's coming in down the water main at 60 psi, goes in the residence at 55 psi. Well, if we have a water main break that occurs because a hydrant got ripped off, we're going to say this is a really old hydrant and it ripped off the main too, because we yesterday talked about the fact that there's a flapper valve and so on and so forth at the bottom of this thing that just remains shut even if it breaks off. All right. So if a water main break occurs out in the water system goes to either zero pressure or negative pressure. Negative pressure, zero pressure also creates a vacuum within the system. And then the water could backflow from a residence out into the water main due to a vacuum, okay? A vacuum created within the water system and a backflow event that occurs due to vacuum is called backsiphonage, okay? Backsiphonage is a vacuum in the water system, and it has two main causes, either water main breaks or fire suppression systems, or fire suppression going on, like firefighting, right? What's a fire truck? It's a great big pump. So that thing is a vacuum when it hooks to a fire hydrant, all right? So another event that occurs, as you see here under normal, we're at 60 psi, and then there's a booster pump within a residence causing a higher pressure. And these can be typically on your lawn irrigation systems. All right, so if a lawn irrigation system has a booster pump to ramp up the psi for the sprinkler heads, that pump is generating a higher pressure than that of the water system and could create a backflow event that way too. Another common cause for back pressure, because this is considered back pressure. there is a physical device within the premises creating a higher pressure on the user side than the municipal side. The other main cause for this is typically boilers, all right? So it's either gonna be a pump or a boiler causing a back pressure event typically. All right, so back pressure, here's a boiler, back siphonage. If you have something like this and a water main break occurs, the vacuum is gonna suck the water back out. So just at this picture is this back pressure, back siphonage. You see the dog, the dog has a straw going into the toilet here, and it's a sucking action. So it's a vacuum, it's back siphonage, all right? So why are they issues? So first off, you need to know the difference between a high hazard and a low hazard, all right? A high hazard is something that will cause immediate health issues, illness, sickness, or death. We talked about fertilizer cans on a hose. That will make you sick almost upon drinking it within a few hours of it. So that's what we considered high hazard. The health risks imposed by the chemicals or ingestion of these will cause some sort of illness, sickness, or death. We like to call those high hazard things. And these can vary upon what they are. Now, low hazard, think about you have a family member that has a house, or maybe even you have a house out in the middle of, not the woods, but in a rural area or rural community, and you have iron in your water, okay? So you might have some rust stains in your tub or in your sink or on your clothes or whatever, but you can drink the water. It might not taste great either, but so the water doesn't look good, it doesn't smell good, and it doesn't taste good, right? But if it poses no medical health risk to people, that's considered a low hazard. So it's kind of like the iron water in your well. Does it smell good or look good? Nah, it's debatable. Tastes good? Definitely not. But some people do have affinity for that. So low hazard is the physical characteristics of it, but it won't make you sick. We also like to call the look good, smell good, or doesn't look good, doesn't taste good, doesn't smell good. We like to call those the aesthetics of the water, all right? So there are 5 types of backflow prevention that we are going to be talking about. 3 of them are assemblies, and one is a device, and the other is a device sometimes, and sometimes it's just a physical separation. So we have the air gap, the reduced pressure principle backflow preventer, supposed to be its full name, or what we like to call a reduced pressure zone, or RPZ for short. Double check valve assembly, pressure vacuum breaker, and then atmospheric vacuum breakers, all right? So an air gap is the physical separation of the discharge end to the potable water pipe, all right? So it's basically a physical separation from the municipal water system and the water coming into to the catch basin or apparatus or whatever it's being sent down into. There is a rule of thumb with air gap. The air gap is supposed to be 2 times the diameter of the discharge pipe. So a 3-inch pipe would have an air gap of a 6-inch, if that makes sense. The other part that goes along with that rule is no less than 1 inch and no more than 12 inches. And the reason no more than 12 inches is because the surface tension of water cannot reach more than 12 inches before it breaks. Here's some examples of air gaps. Your sinks have built-in air gaps here. And as you can see, this is a drain pipe into a discharge basin for like a drain. You see this in commercial kitchens a lot. We recommend that if you are discharging into a basin, that these discharge pipes like this be cut at a slant, because it doesn't allow the mushrooming of water to occur at the bottom of it. The next one is the reduced pressure principle backflow preventer assembly, or RPZ for short. RPZs are considered the top protection behind an air gap. This is a mechanical device that has 2 spring-loaded check valves within it and a relief port. All right. So how does it work? The water comes in from upstream. Typically, it'll go down here first, and it closes the relief port. So the relief port on the RPZ is filled from the upstream side. As it is pressurized, it closes the relief port. The first check valve opens, and always there's a little bit of discharge in water when these first operate. So RPZ should be installed downstream of the meter because the municipality should not be paying for wasted water. And then the second check valve opens, and then it goes across. The reason this is called an RPZ, I don't know if there's a picture of it. No, there isn't. Is there's a 5 PSI loss between the first check spring and the second one as it comes out here. That's why it's called the reduced pressure zone. The middle of this device or this assembly loses a 5 psi. And another thing to note is that at any time there's a 2 psi difference from the upstream and downstream flow of this thing, these check valves will shut, meaning these will shut and close and activate. And if it's followed from the upstream, which is on the user side here, if the check valve becomes fouled with some debris, it will dump the entire user system's water out on the ground, all right, as a relief port. So relief ports or RPZs are recommended to be installed above grade. And the reason for that is that relief port, if flooded, will serve as a cross connection on its own, all right? In Michigan, another thing about RPZs is they need to be installed in a warm area, or an insulated box if they are outside, for the fact that they could freeze and bust. So these can be installed horizontally and vertically. And these are typically your high hazard installation assemblies, just so you know. And high hazard things, these are typically installed. Most cities on their ordinances have that at a commercial or industrial service line, an RPZ is an automatic must, regardless of what's going on inside that commercial or industrial building. All right, so this is a double check valve assembly. Oh, another thing, this is good for back pressure and back siphonage. This doesn't differentiate between the two. It's good for both. Double check valve assembly. A double check valve assembly is a low hazard only assembly. It is testable. You can see that it's testable because you see the test ports. It's just like an RPZ where it is testable. So this is considered an assembly also. It has 2 spring-loaded mechanical valves within it here. And this works in somewhat similarity to that of an RPZ. I went too far back by accident. Where it comes, it opens the first check valve and then through the second check valve. It does not lose pressure across these check valves like an RPZ does. These can be installed again vertically and horizontally, but these are typically on low hazard applications. And the most typical areas that you see a double check valve assembly is on a low pressure untreated boiler, because the fact that they're low hazard, they can't be associated with anything that has chemical treatment beyond it, because if they are, that's considered a high hazard. You see them on low pressure, so pretty much boilers that are heating boilers is where you typically see them, or you can also see them on fire suppression systems as long as there's no additives to it. Those are the 2 most common places you see these things, all right? So another place that you will see them, but they're non-testable, are in beverage machines. So if you're conducting a inspection of a gas station or so on and so forth, you should be looking for these on your when you're inspecting pop machines, cappuccino machines, and so on and so forth. This is an ASSE 1022 device. All right, it's non-testable, but it is known as a vented double check valve. All right, these should be on all of your beverage machines. This is another backflow preventer that is you see on boilers, home boiler systems a lot of times too, but they're not something unless it's hooked directly to your water system that you necessarily need to look at either. All right. So which one is which? Okay, so a double check valve assembly and RPZ. The differences between the two is a double check valve assembly is for low hazard only. It does protect against back pressure and back siphonage, but it's low hazard only, where it's an aesthetic issue possibly if a backflow event were to occur. This is an RPZ, and the differentiation between two, this is high hazard, low hazard, back pressure, back siphonage. But you see the relief port here. The relief port here is the dead giveaway because there's not one on the double check valve assembly, but there is on this RPZ. The relief port is a dead giveaway when looking at these things if you're trying to figure out what you're looking at, all right? The next thing is a pressure vacuum breaker. And the thing about a pressure vacuum breaker is this is typically used in lawn irrigation systems. That is, it's not to say they're not used elsewhere, but lawn irrigation systems is where you see probably 95% of them. They do also get used on marinas that have boat slips, and also at funeral homes. You can see these things too. So the thing about a pressure vacuum breaker is they are for back siphonage only. They're not for back pressure, because if you had a pump downstream creating back pressure on this, what will happen is the water comes in, it closes the check valve and closes the port out the top of this. and the water kind of just goes around under normal flow. But if you have a pump, say over here downstream from it, on like an all irrigation system, that pump could generate pressure and then come back up the pipe and hold open the check valves, so that if there's any sort of chemical additive to that lawn irrigation system, it will backflow through the pressure vacuum breaker. The other thing that's really important when looking at these or inspecting these is that the crown of it or the cap of it be pointed directly up towards the sky. If you walk up to one of these and inspecting them on a house, these are testable, so these are considered assemblies. As you see, they have test ports here. If you walk up to one of these and you see the crown or the cap of the pressure vacuum breaker looking straight at you versus pointed up, it's not installed properly. They need to be installed in the vertical position. These must also be used, so if they are used for lawn irrigation systems, they need to be need to be 12 inches higher than the highest point of use. All right, so think about like wherever the highest point of use is, they have to be 12 inches higher than that. You are allowed to have valves downstream of these too. All right, they must be installed in the vertical position. They are high hazard and low hazard, but they are only for back siphonage. They cannot be any sort of thing that creates back pressure beyond these, or it will not work. All right, properly. So the next thing is an atmospheric vacuum breaker. The thing about an atmospheric vacuum breaker is these are non-testable. You don't see any test ports on these. You typically see them in lab sinks, mop sinks, and you also see them on hose bibs outside a house. These have became the standard since oh man, it was like 96 or something. They became a standard on hose bibs, meaning they're going to show up on all of your hose bibs, or should at least if properly constructed. So these work in the principle. Oh, there's not a picture of them, is there? Oh, you're right. Not really. There's a floating block inside of this that floats up when the water comes on. It pushes the block up and it goes around through normal operation. This again is for back siphonage only. And another thing about this is you cannot have a valve downstream. It is really important to note that difference between the two, that you cannot have a valve downstream from this, all right? And the reason for the no valve downstream is because if you have a valve downstream of this, it will leave the line pressurized. And for the fact this is not a mechanical spring-loaded device, it will allow water to backflow through it because it leaves the line pressurized with a valve downstream. So they're not to be subjected to continuous flow, no more than 12 hours of continuous flow and pressure to this thing, because that block inside of this could be become lodged up here, okay? Again, not allowed to, it's supposed to be 12 inches higher than the highest point of use. Not any higher than that. And these low hazard, high hazard, back siphonage only. Like I said, hose bibs, you typically see them in. Laboratory sinks and janitor sinks are the most common area for these things. It's not, they are also built into the toilets and so on and so forth that we see too, all right? Here's some examples of atmospheric vacuum breakers. You can see here they're being used on a lawn irrigation system. Here's one at a sink in a mop sink somewhere. This is what the hose bib ones look like. It comes out from your plumbing within the house, as you can see here. And it's used, this is a frost one. There's a rubber gasket inside that pushes water out of these things. So, all right. This right here is what we call a hose bib vacuum breaker. So if you run across the house that's really old and doesn't have atmospheric vacuum breaker into it, you can get these little things. Most cities hand these out as they're going around doing inspections on stuff, just because it allows cities to create a backflow preventer on a hose bib that does not have one built into it. And this creates a little air gap here. As you can see, the water ports here, it will drain water out those instead of backflowing. So which one is which? So here is your pressure vacuum breaker. You can see that has spring-loaded valves in it to keep it from shutting. And then this is just a floating block, like I was indicating. It uses the atmospheric pressure from outside of the device itself to go ahead and close everything. So that's how this works. It's an atmospheric pressure. These are mechanical. No valve downstream, valve downstream. All right, that's another thing to note about these. So here is a very good summary about them and understanding what an air gap is and how they work. So an air gap technically is the best, all right? And the reason for that, okay, just so you know, this is supposed to be 12-inch. These are 12-inch from the highest point of use, okay? For both of these, not 6, it's 12. An air gap, though, because it's not a mechanical device, it's the physical separation of things, it is considered the best for this. Does it mean that it has a lot of practicality? Yeah, to be honest with you, no, it doesn't have all that much practicality. Okay, let's see, given that, the cross connection control program. This is a program that is required under the Safe Drinking Water Act, and it is also something that requires our cities to have ordinances on so that they have something that's enforceable, which spells out the inspections, the testing, record keeping, and enforcement and public education on these things, all right? It should be very clear and concise, and it needs to be approved locally because each system is going to be different on what they decide to put in as ordinances, okay? So inspections, so inspections are required by the law. There's forms and record keeping that is required. And then you're also supposed to be giving this to the state on a yearly basis. They're going to be asking how much of your devices and assemblies were inspected and how many of them passed, failed, and so on and so forth in your cross connection control report that's due. Sometimes you have to do an initial inspection and then a follow-up because you may have found something that needs required to be tested or fixed. All right, so inspection's key. Residential inspection is something that the state is going to start. The state already enforces it and looks at the local programs, but the state is really going to start coming out with more like guidance on it in the short term, because there was new rules that were implemented that talked about different testing frequencies and so on and so forth with stuff. So, and I know it imposes a big thing, but it depends upon what everyone's local ordinance says and what was approved by the state on how certain inspections should be done. All right. So let's talk about isolation and containment. Okay. So think about the building that you're sitting in. There's a water line that comes to the building you're sitting in, and there's probably multiple different parts of that building, right? But let's say that a backflow event occurs in that building. Well, if it's contained to that building because there's an RPZ on the service line, so that means it's contained. It's containment. Does that make sense? So everyone in the building is affected by the backflow event, but the system is protected. The water system itself is protected because the backflow event didn't make it beyond the service line. It affected the whole building, sure, but it didn't make it beyond the service line, so that's contained or considered containment to that building. Now, let's say the building you're sitting in has multiple different parts of the building, right? It's got I'm assuming distribution. Most of these people are DPW workers, so it's got some offices, a break room, and probably your DPW garage, right? Well, let's say there is a backflow event in the DPW garage. Well, if each one of those 3 different areas of your building, the garage, the break room, and the offices, all have different service lines, but they have a RPZ or some sort of backflow preventer on each individual one of those lines, it's going to isolate it to that particular part of the building. So if it's in the DPW garage that the backflow event occurs and you have an RPZ on it, it's going to isolate it to the DPW garage. So the people in the offices and the break room would not be affected. That is considered isolation. That means a part of the building is isolated from the rest during a backflow event. So it doesn't affect everyone. It only affects the people in that particular area. So isolation is preferred because it doesn't put at risk all of the building's inhabitants. It only puts at risk the people in the area where the backflow event occurred. And in some instances, it's now starting to become cheaper to do isolation versus containment. And the reason for that is RPZs are almost at a going rate of $1,000 an inch for installation and purchase at this point. I just heard maybe a month ago, a 1-inch installation of an RPZ was like $850 to $950, somewhere in that range between buying it and having a plumber come and install it. So it's pretty close to $1,000 an inch at this point. And that's quite substantial. Containment, sometimes it's best. And most cities require containment regardless of what weather recommendations are. It's all part of their city ordinance under their cross-connection control program. And the thing about it is containment is almost an always must in every city. And it's because A, the user doesn't have to let you in to see what they're doing in that facility. And B, a lot of times in big industrial buildings, the plumbing's untraceable. It's really hard. It goes behind this wall, and where does it go after that, right? So containment is almost always required by any city when they have commercial or industrial applications for this, all right? So let's do a quick example of what it might look like, right? So here, as a quick example, we have a building here. It's got a treated boiler, lawn irrigation, plating, and non-treated boiler, right? So you have the water line come in, and here's the meter, and downstream of the meter, you just put an RPZ. So if a backflow event occurs, the entire building here is affected if like the treated boiler backflows or the plating backflows, right? But the thing about it is the water system over here in the water main is protected because of the RPZ. Testing. Where's the isolation event? Okay. All right, testing. So we need to talk about this because there's one that's missing here, obviously. So there are 3 different testing frequencies that are required. High hazards need to be tested yearly. Every single year, high hazard assemblies that are being used for high hazard application. So a funeral home, a chemical plating factory, something like along those lines. Those need to be treated every single year because they're considered high hazard. So they need to be tested every single year. Low hazard applications need to be done every 3 years, okay? Now lawn irrigation systems are, as long as they have no chemical additives in them and it's just a lawn irrigation system, lawn irrigation systems are tested every 5 years, if that makes sense, all right? This is actually that picture is a bad installation of an RPZ. I could tell it's an RPZ because I see the fill port for the relief port down here, but it's also bad because it's buried. I see this could get wet, and that's not good. All right, so why do we test? We test because these are mechanical assemblies. They can fail. All right, to sit there and think that this thing's going to live 100 years and be perfect there all 100 years, that won't ever happen. All right. So what happens with these, and as you can see, this is a pressure vacuum breaker. And what's funny about it is here's the meter, but there is a booster pump there, isn't there? And what happened to it? The booster pump destroyed it and blew it apart. So we need to test these to ensure that they are in proper working order so that these things will prevent a backflow event from occurring and affecting public health. That is the biggest reason why we test these things, all right? And this is just some pictures of it, all right? And as you can see here, this is an air gap device on the bottom of an RPZ. See the air gap device here and an RPZ up here. It's to help funnel. There's a video here. You know, we're not going to watch the video though. I'm assuming it is it dumping the water out from the looks of it. It looks like to me. Record keeping. It's important for record keeping because the state, when they do their sanitary surveys, are going to be looking at this stuff. And there's an annual report along with the information that is to be submitted to the state as of March 31st every year. And the state's going to be looking for testing sheets and inspection sheets upon looking at this stuff. So of your low hazard devices, being that they are to be tested, so let's say you have 1,000 of them on your record. Being there to be tested every 3 years, the state expects that 33% of your low hazard devices should be tested every single year. And all of your high hazard assemblies should be tested too once a year. So that's stuff that you can expect that the state's going to be looking at as the metrics and the numbers to make sure that you as a municipality are meeting those metrics. All right. Here's kind of what an example of an inspection report looks like. Enforcement. Sometimes it is necessary. Sometimes you have a homeowner, a residential, or even commercial or industrial that are refusing to have things tested. They're refusing to install the proper backflow preventers that are needed for the application that they are, you know, there for. And sometimes you can inform them via giving them a correction notice if your policy states that they have such and such time or 30 days to make corrective action, and you will be back to inspect. And then if they don't, sometimes it ultimately needs to remain end in a shutoff. And the reason it needs to end in a shutoff is for the fact that we are looking to protect public health with cross connection control programs. So it may cause this one person not to have water, but if it's the benefit of the entire system to not be sick or poisoned or something along those lines, then it is what it is. So that's what it comes down to sometimes. All right. And public education, one of the biggest things with this is trying to understand and get your residents to understand through education why it's important. Why do we do these things, right? And I mean, if someone can't get it, that is for public health. I mean, I don't know where else we can reach. So doing it is learning the terminology, breaking it down, and making things easy for people to understand is the biggest thing here. And you can do it in multitude of different ways, right? You can do it through public speaking. You can do it through mailers. You can do it through videos. You can do it. Social media is a big one now too, right? And something along those lines. So holding forums and so on and so forth, public education is one of the biggest things that you can do. All right. Residential cross connections. Absolutely, it is a required program, but we all know that it is going to be hard. But the biggest things you need to do with trying to gain access to different homes and so on and so forth is educating the individuals, applying upon them the law and rule requirements for testing and inspections so that they understand. And then having a local ordinance in place for this so that you have something that can show, if you don't let me inspect your house, not saying you have to go in it because everyone's local ordinance is different, right? It might be such a thing, so on and so forth. It might be just an outside perimeter inspection to see if they got lawn irrigation, hose bibs, and so on and so forth, all right? Because you don't have the legal right to go in their house, all right? So the biggest thing is to make a plan, get a local ordinance, approach your city council and get it approved. Formally update the written program, meaning if you already have a program, you should be updating it because rules have changed for this, right? No one, in order to be able to test these assemblies within the state of Michigan now, you have to be an ASSE 5110 certified person. And no, that does not mean every single plumber on the planet is a tester. Okay, they can if as long as they're licensed, they can install it and they can repair it, but they cannot test it unless they're ASSE 5110. If you go to ASSE's website, you can find a list there of people who are certified in your area, just so you know, to do the testing. All right. You need to make sure in your local ordinance that you have some sort of teeth for enforcement. If you do not comply with having tests done or inspections done to your area, we're going to shut you off, right? Because one of the biggest things you can do is you shut off a customer. That changes their whole story on a lot of things real quick. And gradually, don't do this and come out and immediately be, like a strongman enforcer. Like, I'm going to just shut everybody off because they didn't let me do whatever. You got to take a sensible approach to this with your residents, because if you want your job to be easier, you need to make them understand why you're doing it, how you're going to do it, and so on and so forth, because a lot of people will be easier to comply with than just going out and try and strong arm someone into something. All right. So the old system for testing, a licensed plumber is the only person who could do it, and they were certified in the state. Well, no longer a licensed plumber. It can be any. If I was licensed to, or you, let's say we're certified as an ASE 5110, you could test the assemblies, right? This became enforceable as of January 1st of 2018. They cannot make repairs. That is due to be done by a licensed plumber, all right?